Trigonometry, Chapter 3, Radian Measure in the Unit Circle, Section 3, the Unit Circle and Circular Functions. Video 6, Introduction to Ranges of Inverse Trig Functions. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we revisited the domains and ranges from the perspective of circular trig functions. In this video, we briefly look at the ranges of three inverse trig functions, cosine, sine, and tangent. In a past video, section 2.3, video 2, we discussed using inverse trig functions to find acute angles. At the time, we were limited to just acute angles because we had not yet needed to use inverse trig functions to locate angles outside of quadrant 1. However, because of the periodic, repetitive nature of trig functions, for any given value in the range of a trig function, there are an infinite number of angles that could produce that value. For example, consider cosine of theta equals 1/2. Knowing what we know about the unit circle now, that cosine of s is the x-coordinate, we can easily see that theta is equal to pi over 3 and theta is equal to 5 pi over 3 are solutions. In other words, if you look at this ordered pair whose x is 1/2, pi over 3, and down here, this ordered pair whose x is 1/2, 5 pi over 3. So there's two solutions. But in addition to those two being solutions to cosine of theta is equal to 1/2, so are all angles coterminal to both. So all solutions to this are the set of s's such that s is equal to pi over 3, our first solution, plus 2 pi n, or s is equal to 5 pi over 3, our second solution, plus 2 pi over n, where n is any integer, so an infinite number of solutions. This presents a problem when evaluating cosine inverse of 1/2. Which of those infinite number of solutions to cosine of theta equals 1/2 do we use? Well, to truly make inverse trig functions functions, meaning they can only produce one output at a time, we take the corresponding trig function's domain and restrict it as the range of the inverse trig function. Later, we'll go into detail about how these restrictions are made. For now, we would just list them for cosine, sine, and tangent. Cosine. The domain of cosine is all real numbers, and the range is -1 to 1. For the inverse trig function, we have to go in reverse. So the domain of inverse cosine is -1 to 1. But the range of inverse cosine is just 0 to pi inclusive, as opposed to all real numbers. This range limits outputs of inverse cosine to a unique value. These are all going to be summarized at the end. Sine. The domain of sine is all real numbers, and the range is -1 to 1. So if we reverse that for the inverse function, the domain of inverse sine is -1 to 1. But the range of inverse sine is just closed interval, -pi over 2 to pi over 2, as opposed to all real numbers. And again, this restricted domain of sine as the range of inverse sine limits the outputs of inverse sine to a unique value. And similarly for tangent, the domain of tangent is a set of all s's such that s is not an odd multiple of pi over 2, where n is not equal to 2n plus 1 times pi over 2, where n is an integer. Visually in the unit circle, it means any points except ones that stop at the top or the bottom of the unit circle. And the range is all real numbers, -infinity to infinity. So for the inverse tangent, we need to reverse the domain and range. The domain of inverse tangent is all real numbers, but the range of inverse tangent is just the open interval, -pi over 2 to pi over 2. Neither of those are included because tangent is undefined at both of those. You can check that. And again, limiting the domain of tangent to this interval as the range of inverse tangent limits the outputs of inverse, that should say inverse tangent, to a unique value. I'm not going to re-record the video, but I will make a correction here. This should say inverse tangent. That's what happens when you copy and paste and don't catch all the changes. All right, so here's the summary of all the domains and ranges of these three inverse trig functions. What about the reciprocal functions, secant, cosecant, and cotangent? We'll talk about those later when we formally discuss inverse trig functions, domains, and ranges. For now, just understand that these functions, and your calculator knows this, have very limited ranges. Cosine inverse will always produce an answer between 0 and pi. Think of it as quadrant 1 and 2. Sine inverse will always produce a value between negative pi over 2 and pi over 2. Think of it as quadrant 1 and 4, where you reach quadrant 4 by going backwards instead of forwards. And the range of tangent inverse is the same as the range of sine inverse, except it doesn't include the endpoints because tangent is undefined at both negative pi over 2 and pi over 2. No problems to try here.